answer key for the quiz is on Moodle. If you've got questions about it, please feel, and want to work through some things, please feel free to stop by my office. I'm happy to go over things always. Are there questions before we get started on some new stuff? All right. Okay. Well, we talked about how we defined the trig functions in terms of right triangles, right? We had sine was opposite over hypotenuse, cosine was adjacent over hypotenuse, and so on up the line. But if we're defining them in terms of right triangles, we're stuck with our angles to be between 0 and 90 degrees, or 0 and pi over 2, right? If we're going to keep it inside of a right triangle. We want to extend these notions so that we can do this for any angle that we want. We don't want to just have just the acute angles in there. We want to be able to do things for bigger angles. So here's the idea. When we have, well, let's say my angle was over here to start with. Say, and again, we're in standard position, so the initial side is along the x-axis. So the side that I drew in here would be the terminal side. Well, I can figure that one definitely is an acute angle. So one way we could do figure out the trig functions on that is make a perpendicular line, come down to the x-axis, and make a right triangle, right? We agree? Okay. So if this side where your length say x, and this side where your length say y, and the reason why I'm using x and y here would be because I could think of the coordinates of this point being here, x and y. Then x is my horizontal distance, my y is my vertical distance, right? We could figure out, if we know what x is and we know what y is, of course, we can figure out the length of the hypotenuse using Pythagorean theorem. I'm just going to label it with a letter for the time being. There's reasons why I use this particular letter, but it'll be important later on in the semester when we talk about what we refer to as polar coordinates. So I'm just going to label it as R for right now. R is the length of the hypotenuse here. You can also think about a circle being centered at the origin. What that is the radius. That's why we use the letter R. I didn't draw the circle in there, but that's why we use the letter R there. Notice that if I have this configuration, then I can define my trig functions of theta using those letters, right? What would sine of theta be in terms of the letters that I put on the triangle? Y over R, right? Opposite over hypotenuse, correct? What would cosine be? X over R, right? And so on down the line. We could do, so your cosine would be x over r. Tangent would be y over x. And then we can do the other ones as the reciprocals. Cotangent would be x over y. Secant would be r over x. And cosecant would be r over y, right? So notice that we have these 6 trig functions defined just in terms of x, y, and r, and I got the x and the y by where I put that point on the terminal side, and the r we can figure out if we know what the x and the y are, right? The r will always be positive. We think of the r as a distance from the origin, right? Think of r as a distance. Or if you think about Pythagorean theorem, you'd have square root of x squared plus y squared. So if you're doing a positive square root, we always have to consider that positive. And so your hypotenuse here will always be positive. But again, if I know x and y, I can figure out the right triangle there and get those values. So turns out that there's nothing special about that particular thing being in the first quadrant, being between 0 and 90 degrees. if we would have instead put your theta, say, over here, I'll try to draw a slightly different, bigger angle there. If this is your theta, well, I could still have an x and a y coordinates on that particular side, right? It's just in this case, your x would be what? Negative, right? Because we're to the left of the y-axis, right? I could have also, and I'm going to draw it down here because my picture will get all sorts of messed up, but if you were to draw it down here and put your x, y coordinates, your x and your y would both be negative, right? Over here, which one would be negative? The y, right? So this is how we're going to extend our notions of the trig functions to angles that aren't just between 0 and 90 degrees, or not just between 0 and pi over 2. Okay? We're going to consider those coordinates being the important parts of figuring out whether it's going to be positive or negative. And so that's where the idea of what we refer to as reference triangles and reference angles come in. So let me kind of redraw that last one that I put on there. Here's my theta. What we mean by a reference triangle, I'm going to draw it in and then I'll write it in words, but I think it's a lot more descriptive just to draw in how the picture works. To create what we refer to as a reference triangle, we're going to work off of the terminal side, and you're going to drop a perpendicular down to the x-axis. This is what we mean by our reference triangle. So the reference triangle is it's a right triangle created by dropping a perpendicular from the terminal side of theta to the x-axis. It's always to the x-axis, by the way. Always drop it down or drop it up. Or drop it like it's hot. Right, not that one. Okay. All right. So drop it down or dropping up. So it's always going to the x-axis. No matter where the terminal side is, it always goes to the x. Okay? That's how we create the reference triangle. These reference triangles will help us figure out the sines and the cosines because we created a triangle here. I've got a right triangle. I know how to deal with sines and cosines in right triangles, right? Okay. So we're going to use these right triangles to help us out. What do we mean by reference angle? Well, the reference angle is the angle that's formed between the terminal side and the x-axis. I'm not sure because I didn't remember to look at the book before I came into class today after I made this handout. A lot of books will put a tilde over the top of the angle that you're referring to refer to the reference angle. Okay? So the reference angle here is the acute angle formed by the terminal side and the x-axis. Technically, what I wrote there is not 100% precise, and I'll talk about how it's imprecise here in a minute. But right now, you can kind of see the acute angle, right? So let's go with what we see, and I'll handle the special cases in a little bit. Okay. All right, so that's what we mean by a reference angle. It's an acute angle. In particular, it's a positive angle. All right, we're not worried about a negative angle, and it's less than 90 degrees. And we already dealt with positive angles that are less than 90 degrees. We came up with how we figure out the sines and the cosines of those, right? Okay. So that's exactly what we're going to use to help us out to figure out the different values for sines and cosines of different angles. So let's see how that works. Okay. So the first thing we're going to do is just compute some reference angles. And then we'll use reference angles in the next one to figure out exact values. So let's just see if we can find the reference angle by what I mentioned. So the first problem here is asking us to find the reference angle for a 148 degree angle. So I think it's I think it's helpful here, in my mind. I think it's helpful to draw a picture and see what's going on, and then see if we can come up with a kind of a general rule later on. Okay. So if I draw my picture, which quadrant should your terminal side end up in? If I have a 148 degree angle, which quadrant? 2, right? We should be, again, we're starting off the positive x-axis, rotating counterclockwise, right? Up and to the left. 148 degrees is past 90, but not quite to 180, right? So your 148 degrees should go this way. I'm going to draw the reference triangle in for reference, but really we're just trying to figure out what the angle is because it's asking for the reference angle, right? Again, we create our reference triangle by dropping that perpendicular. So your reference angle is in here, right? How would we find out what that theta tilde is? How would we figure out what that reference angle is? Yeah, exactly. It's a supplement, right? The two angles together make up a straight line. So I can figure out what the reference angle is by doing the 180 degrees minus the 148 degrees and get what? 32? Okay. So we do the other ones the same way. Let's see if we can figure out what they are. Negative. I'm going to draw the picture for reference, and then see if we can figure out how to. Like I said, we're going to draw the pictures for reference, and then see if we can figure out kind of a general way to do this to help us out. What quadrant are you going to end up in if you do a negative 372 degree rotation? Be down. Yeah. So negative means I go which way? Up or down? Down. So I have to go all the way around as negative 360, so I've got another little bit to go, right? So you'll end up in quadrant 4. Good. So again, the reason why we ended up in quadrant 4 is because I rotated the wrong way. Because we rotated that way, right? Yeah. Cool. Notice that in this particular case, we've gone all the way around, and then we went just a little bit more, right? How would you figure out what that little bit more is? Yeah, subtract the 360 off of it, right? Notice that this little bitty angle that's in here is coterminal with the one that went all the way around, right? Well, we know all the way around is 360. Yeah? Okay. So if I measured this way, measured down, that would still be negative, right? Be negative what? What would be the value? It'd be negative 12, right? 372 minus 360 is 12, yeah. But negative is not a positive angle, but how would I figure out what the reference angle is? Instead of it being negative 12, the reference angle would just be positive 12, yeah, because it's the acute angle, right? So again, if I draw in the picture, oh, hey, that was an ugly looking line. If I draw in the picture, my reference triangle, I mean, this angle right in here would be positive 12 degrees. The reason we got positive 12 again was because we did the negative 372 plus 360, got the coterminal, right? But instead of measuring down, we just measure up. in a positive direction, it gives us a positive 12, right? This value, if it's negative, if you ignore the negative and you put it between 0 and 90, that is your reference angle. You don't have to worry about the negative. Yes?
So is it always going to be positive, the reference angle?
The reference angles are always positive, yeah. By definition, they're always positive and always less than 90. Every time. Yep. It's a good question, but yeah, they're always going to be positive. That one okay? Cool. All right. So those were the degree ones. Let's see if we can figure out the radian ones. I need 19 pi over 11. That's kind of better fraction. Got to figure out where 19 pi over 11 ends up if you rotate around. All right, so if I go all the way around, what is that? 2 pi, and how many 11ths would 2 pi be? 22, right? Agreed? It'd be 22 pi over 11 if we went all the way around, so we're not all the way around quite yet, right? Okay? Halfway around is pi, which is 11 pi over 11, right? So it's somewhere in between. This would be halfway, right? Is 19 bigger, farther than halfway, or less than halfway between 11 and 22? Farther. So which quadrant are you going to end up with if you're rotating around this way? Fourth again, right? We're going to be down here. You agree? Okay. So all the way around here somewhere will give you 19 pi over 11. Again, this is what I want, right? That's my reference angle, and I want it to be positive, correct? Okay. So what can we do to figure out what theta needs to be in this case? Subtract it from 2 pi. That's exactly right. If we go all the way around this 2 pi, and I subtract that piece off, that should give me left what I need, right? That should give me the reference angle. You told me a minute ago that 2 pi was 22 pi over 11. So if I subtract, I should get 3 pi over 11. That would be the acute angle. This process okay so far? Basically just drawing the pictures. So notice what did we do in a couple of these? When it was in quadrant 2, we did the supplement. Here we just made it positive, right? Because we just did coterminal, made it positive. It was in quadrant 4. Here, I could have done this. I could have found the coterminal angle by subtracting 2 pi and then made it positive, which is essentially what we did, right? Just figure out the rest of the piece. Let's do this next one. I'm not sure the next one illustrates what I wanted to do, but that's okay. We'll talk about the other one here in a second. Negative 48 pi over 13. Big number. All right. So first, start on the positive x-axis. Do we want to go up or down? Down. Good. All the way around is 2 pi. So how many 13ths is that? 26, right? If I go another pi, that's another 13, plus the 26 is 39, right? And then all the way over here would be 52, if I came all the way back around. 48 is closer to 52 than it is 39, so it must be in quadrant 1. So somewhere over here, we went around and around that way. Right? You see why we ended up there? Got to figure out where we ended up to figure out what the reference angle is, right? So if I just start counting by 13s, 13, 26, 39, 52, so I know it's in between those two, and 48 is closer to the 52 than it is the 39. So it has to be in quadrant 1. So again, now I want this angle. How are we going to figure out that angle? Yeah, good. Because notice if I think about this completing the circle, I've gone once, twice around, haven't I? Right? That twice around the circle would be 4 pi, and then subtract the 48 pi over 13, which gives you 4 pi over 13. Do one more because the one quadrant we didn't end up in was 3, right? So what if you had something like theta is, let's say, pardon me, goodness, let's say 15 pi over 14. Start rotating, I would go, which way, up or down? Up. So halfway is how many 14ths? 14. So I go one little bit more, right? So I'd be over here. So I went halfway and a little bit more, so that would end up in quadrant 3. What would we need to do to figure out that theta in this case? Subtract pi from it, right? We just need to cut off that halfway around piece, don't we? Agreed? Okay. So in this case, your theta tilde, your reference angle would be pi over 14. So when you're doing these reference angles, you're probably going to be dealing with either pi or 2 pi or 180 or 360 to be able to figure out where you need to end up. Does that make sense? Notice in the first one we did, since it was in quadrant 2, we did the 180 minus the angle. Over here, we did the angle minus the 180 essentially, right? It was in quadrant 3. So again, when you're figuring out what these reference angles are, you're basically going to be playing around with pi or 2 pi to figure out what the acute angle is, depending on where you end up. All right. So let's see if we can put this to use on these problems. So remember, just to remind ourselves, we've got the special angles. "30, 45, 60 were special, right? If this is your theta, your sine of theta was what for 30? Does that use a 30, 60, 90 triangle or a 45, 45, 90 triangle? 30, 60, 90, right? So if I've got 30 here, remember that the opposite side is 1. Square root of 3 is the adjacent. 2 is the hypotenuse for 30, 60, 90. So what would the sine be? 1/2. Good. Yep. And then 45 degrees would be 1 over square root of 2. Good. And 60 would be? Good. Yeah, square root of 3 over 2. Exactly. Right? Yep. What's cosine look like? Yeah, square root of 2 over 2 or 1 over root 2, either or, yep. And the last one's 1/2. Notice that they're in the reverse order, right? They're the exact same values, they just go in the reverse order. Once we know these, we can figure out everything else with two exceptions, and we'll talk about what those exceptions are here in a minute. But we can figure out every other one that you are asked to do the exact value of comes back to these. If you can remember those three angles and those six values, you can do absolutely every single one that you'll ever be asked to do for exact values. I promise. Okay? Except, well, I promise, except for the special ones that end up on the quadrants, but we'll talk about those in a minute. Okay? If you can remember those, you can do every problem. Okay? And the way we do that is with reference angles. So let's look at 150 and see if we can figure out what the reference angle is. And then we'll also draw the triangle. Okay? So let me draw this off over to the side here. What quadrant do you end up in if it's 150 degrees? Second. Good. 150 degrees is over here. What's that make your reference angle here? 30. Right? So here's my reference triangle. Notice that your reference triangle here is a 30, 60, 90 triangle, right? I made a right triangle. One of the angles is 30, the other has to be 60. So the reference triangle is a 30, 60, 90 triangle. So I can put these values on this triangle, but I want to be a little bit smart about it. Because remember when we talked about extending the definitions of the trig functions, I use the point x, y here on the terminal side, which is going to be negative on this one. The x or the y? X, right? So when I put my 30, 60, 90 triangle down here, I'm going to put the sign of it, the SIGN, whether it's positive or negative. I went left, so my x coordinate's negative, so I'm going to put a -1 on that side. Does that make sense? Okay. Or not that side. Well, it's not -1. I'm going to put a negative on that side. I lied. Where's the 1? The opposite, right? This x is -√3. Sorry. That's the bigger side. I flip-flopped them. Your hypotenuse is 2, right? This is why I said you only have to remember those values. Because notice these values are going to pop up here in my reference triangle. I just have to worry about if it's positive or negative, right? And that's going to depend on where they end up. Now I look at that, if I want the sine of 150 degrees, this will be the same thing as the sine of 30 degrees. Is it going to be positive or negative based on your reference triangle? Well, my reference triangle for sine, I do opposite over hypotenuse, it'll be positive, right? So it's still 1/2. I didn't have to do anything special. I'm just using the reference triangle, right? Figuring out where that terminal side lands, use the reference triangle. And then I notice that my reference triangle is above the x-axis, right? So the y-coordinate's positive, so it's a positive 1/2. If you were doing cosine instead, what would you say? I want a cosine of 150 degrees. Is that going to be, that's going to be either plus or minus. That's the whole point of the reference triangles. It's either plus or minus cosine of 30. Is it going to be plus or minus in this case? Minus, because we're to the left of the y-axis, right? The x is negative. Yeah? Okay. So this will be -√3/2. And again, I can't emphasize this enough. If you're asked to figure out an exact value of a trig function, it's going to be one of those values, unless it's on the quadrants, and like I said, we'll talk about that here in a minute. It's going to be one of those values, either positive or negative, depending on where you ended up. Okay? So you don't have to try to memorize them all. I literally only need to remember those. Everything else you can figure out. Okay? All right, so let's do the next one where it's asking for cosine of -225. Cosine of -225. I'll draw the picture over to the side here. Start rotating up or down. Down. to here is 180, right? So 225 is going to be over here. Let me erase that part. So your 225 went this way. Here's your reference triangle. What's your reference angle going to be in here? 45. Right? 225 minus the 180, right? Agreed? Or you could do 360 minus 225 will give you that one. You get bigger from there, but 225 minus 180 will give you that one. Okay. Now instead of a 30, 60, 90 triangle, your reference triangle is a 45, 45, 90 triangle, right? How do you label your sides in a 45, 45, 90 triangle? Yeah, 1, 1, root 2. That's how we label the sides. Do I need to put pluses and minuses on one or both of them? On the bottom one, the adjacent one here, right? So when I come back up here, this cosine of negative 225 will be the same thing as the cosine of 45, but is it plus or minus the cosine of 45 in this case? Minus, right? Because we're to the left, we ended up in quadrant 2. We're to the left of the y-axis. The x value would be negative, so this will be negative 1 over root 2. So far, so good? Yes. Yeah, 225 would be in the third quadrant if it were positive. We rotated that way, and that's why it's in quadrant 2. You're exactly right. 225 would be in the third quadrant if it were positive. Yeah. That okay? All right. I think you're going to like the reference angle part with the radians even better. I know maybe not necessarily comfortable with radians, but the reference angles are always, for the ones that you need to know, the reference angles are always easy. Okay? So let's do this first couple, and then let's see why they're always easy to figure out. Well, for the special ones that you know, okay? It doesn't work for all of them, but it works for the special ones, okay? All right. So let's look at 4 pi over 3. We've got to figure out what quadrant we're in. That's important. What quadrant are we in? Third, right? Because halfway around is 3 pi over 3, and I need to go another one, right? Agreed? Okay. So how are we going to figure out the reference angle now for that one? Subtract the pi, right? When you take 4 pi over 3 and subtract pi, you just get pi over 3, right? Agreed? Okay. So we know that the tangent of 4 pi over 3, it's either going to be plus or it's going to be minus the tangent of pi over 3. We just got to figure out if it's the plus or the minus and go from there. Okay? So there may be a sign that I need to put in front, either a positive sign or a negative sign. Okay? But it's literally the same absolute value as tangent of pi over 3 is. Okay? How do we figure out tangent of pi over 3? Well, I could try to memorize it, but I don't have to memorize it because what's another way to figure out tangent? Yeah, it's sine of pi over 3 over cosine of pi over 3, right? I don't have to memorize tangent. I can figure it out if I know sine and cosine, right? So your tangent of pi over 3 is sine of pi over 3 over cosine of pi over 3, right? That would be root 3 over 2 over 1/2, right? And if you want to simplify that, you get root 3. But again, I don't have to figure it out. You agree? Okay. So I know that this is going to be either positive root 3 or negative root 3? Has to be one or the other. Can't be both. It's a function, right? Can't get both answers. It has to be one or the other. The question in this case is it positive or is it negative? Well, again, if I think about my reference triangle, what would your x be? Would it be positive or negative? Negative. My y would be negative. Tangent is going to be y over x. Negative divided by negative makes positive, right? So it'll be a positive root 3 in this case. That one okay? Let's do the next one for the reference angle, get the value, and then we'll see that what I've been talking about here about why the reference angles for your special ones are easy in radians. Okay? So let's do negative 9 pi over 4. I need to rotate which way? Down. All the way around is how many pi over 4s? 8. And so I got to go one more down. So we're going to end up down there, right? Because all the way around is 8 pi over 4, and we went downward. So I got to go one more pi over 4. So notice what I said. I went all the way around for 8 pi over 4, and I got to go one more pi over 4. So what's your reference angle? Pi over 4. It's the one more it's the one more that I have to go down, right? All right. Before we finish this off, let's think about why the reference angles here are easy. I started with 4 pi over 3 over here. What did the reference angle end up being? Pi over 3. I started with negative 9 pi over 4. What did your reference angle end up being? Pi over 4. What do you think it's going to be here? Pi over 3. What do you think it's going to be here? Pi over 6. You don't even have to think about it. When it's one of the special ones, the over 3, the over 4, the over 6, the reference angle is pi over that number. You don't have to think about it. That is the reference angle. Okay? Every single time. Now, it's those special ones that work. If it's like pi over 9 or pi over 11, that doesn't work. Okay? But it works for pi over 3, pi over 4, pi over 6. Okay? All right. So, anyway, we would draw our reference triangle again down here in quadrant 4. This way. That's a 45, 45, 90, right? Pi over 4 is a 45-degree angle. This side would be 1, because we went to the right. What would the opposite side be? Negative 1, and then root 2. And then if you want cotangent, what would you do? Yeah, reciprocal at tangent. Tangent's opposite over adjacent. So we would do adjacent over opposite, which gives us negative 1, right? This is going to be the negative of, write it this way, cotangent of pi over 4. Again, if you didn't want the reference triangle and just wanted to go by what you memorized, cotangent is equal to cosine over sine. It's reciprocal tangent, right? So you do 1 over root 2 over 1 over root 2. And I get 1. And it's negative because we're down here. That makes sense? So again, when it's in radians, the reference angle's nice. All we need to do is figure out where we ended up. Okay? To see if it's positive or negative. That's the important part. Okay? So here, this will be the same thing as secant of pi over 3. The reference angle will be pi over 3. We just have to figure out if it's going to be positive secant or negative secant of pi over 3. Literally the only thing we have to figure out. Okay? All right. So 15 pi over 3. I'm going to start rotating which way? Up. Good. All the way around is 6 pi over 3. So then all the way around again is 12 pi over 3. I didn't make that nice. Wait a minute. Sorry. I screwed up when I typed up this problem. Let's edit that. Let's make this 16 pi over 3. Sorry. 15 pi over 3 reduces. Sorry about that. When I made these up, I didn't check it to make sure that I made sense. Let's do 16 pi over 3. That doesn't reduce. All right. We okay with the fact that we've gone to 12 pi over 3 now? All right. Halfway around is another 3, so that's 15. So 16 ends up down here. Sorry about that. The important part is that we ended up in quadrant 3, right? So in quadrant 3, both your x and your y will be negative, right? The x corresponds to your cosine, the y corresponds to your sine, right? We talked about those earlier, right? Sine was y over r, cosine was x over r. Okay. So is this going to be positive secant of pi over 3 or negative secant of pi over 3 since we're down here? Negative, right? Because our reference triangle goes this way, and we have a negative x value, don't we? Secant is 1 over cosine, and cosine of pi over 3 is what? Say it again. That's the sine of pi over 3. It's the other one. That's 1/2. If pi over 3 is 60 degrees, right? So this will be negative 1 over 1/2, which simplifies to negative 2. I apologize for the typo to start with. I wouldn't try to be tricky like that and make you do a weird reference angle that way and make you have to simplify it. I wouldn't do that to you for figuring out these exact values right now. All right, let's look at the last one for cosecant. 6 does not have any common factors with 0.3. Okay. Reference angle. Pi over 6. And radians again, we can, if it's pi over 4, 3, or 6, just lop off the coefficient. Your reference angle is pi over that number every single time. Okay? So it's cosecant of pi over 6. We just have to determine if it's positive or negative, right? So we just need to figure out where 23 pi over 6 ends up, and I'm not going to try to draw circles all the way around this time. I'm just going to count. So up or down to start with? Down. Around and down gives me to 12. Another time around will get me to 24. We're just a little bit short of that, right? So we end up in quadrant 1. So is it going to be a positive cosecant or a negative cosecant of pi over 6? Positive, right? Because everything over there in that quadrant is measured positively. Cosecant is 1 over sine. Sine of pi over 6 is 1 over 2. 1/2. Good. So we end up with 2. So again, once you know what the reference angle is, you know what the sine and cosine are, and you just have to figure out if it's positive or negative, depending on what quadrant you're in. Does that make sense? Are we okay with that? Okay. I said that there were some special ones. We can think about it in terms of triangles, but they're not really triangles. But to illustrate what's going on, I'll think about them as triangles to start with, and then we'll see if we can figure out which ones they are. All right. So what do we mean by a quadrant angle? Well, we literally mean the terminal side ends up on one of the axes. It literally is quadrants make up the angle, okay? So this quadrant angle right here would be how big? The one I just drew in here. Not a trick question. How big is that one? 90, right? So this quadrant angle would be 90 degrees or pi over 2, right? Another quadrant angle would go that way. So you go from positive x-axis to negative x-axis. How big is that angle? 180, which is just pi, right? Agree with that? If I go all the way around, I'm going to make a bigger circle this time and go to here. What's that going to be? Yeah, 3 pi over 2, 270. Good. And then finally, all the way around, we get you to 2 pi, right? When we say quadrant angles, we mean that the terminal side lands on an axis. Okay? Positive y-axis was the 90 degrees. Negative x-axis was 180. Negative y-axis was 270. Right? That's what we mean by quadrant angles. All right. If we want to figure out what the sines and cosines of these things are, let's go back to the ideas of the triangles, right? Because remember when we did a reference triangle, we did x and y, right? This was your xy coordinates, right? Okay. If I think about for 90 degrees, and I put my xy on here, what do you know for a fact the x is? 0, right? We agree? So I'm going to draw a goofy triangle. And what I mean by goofy triangle is I'm going to label this side 0 and the other side y. That's not really a triangle, right? But to illustrate what's going on, I'm going to make it a 0. What would that make your hypotenuse? If this is 0 and that's y, and we do Pythagorean theorem, what would that make your hypotenuse? It'd be the square root of y squared, right? So it'd just be y again, wouldn't it? Now that I have a reference triangle, can I figure out what the sine, cosine, tangent, all those things are for that one? Yeah, right? Because your sine would be y over y, which is equal to 1, right? Cosine would be 0 over y, which is equal to 0. Yeah, you can figure out those exactly the same way, right? So if I go over here and I ask for sine of 90 degrees, you would tell me it is 1. Right? And just to emphasize, cosine of 90 degrees is 0. By the way, if I scroll back up to the table I made to start this off, if I put 90 degrees here, it still goes up that same pattern, doesn't it? It's getting bigger for the sines, it's getting smaller for the cosines. Right? What if we did the other way around? What if you wanted just draw a different picture. What if I wanted a 0 degree angle? What do you think your reference triangle would look like if I did a 0 degree angle? So the x can be anything, but the y has to be 0, right? Because we didn't move off the x-axis, correct? Which makes your hypotenuse equal to x as well, correct? So now what's the sine of 0 degrees? 0, because it's 0 over x. What's the cosine of 0 degrees? 1, because it's x over x, right? So again, if I go back up to my table that we started up here, I can't fit it in very easily. Erase that stuff up there. If I do 0 degrees, this would be 0, and this would be 1. Notice it's the same 5 values, they just go in reverse order, right? 0, a half, 1 over root 2, root 3 over 2, 1, or 1, root 3 over 2, 1 over root 2, 1 half, 0. I have no idea if I'm pointing to the right numbers. Nope, not pointing to the right numbers. So it's the exact same set of values. One goes up, one goes down. So if you can remember one of them, you can remember the other. Not a lot to memorize, even though it seems like it. Okay. Save that brain space to memorize Taylor Swift lyrics when she drops a new album. Okay. Don't waste your brain space on things that you don't have to memorize. Okay. All right. Anyway, let's see if we can do one more here, since we got about 1 minute. Let's look at the cosine of negative 180. Well, negative 180 ends up right there, right? On that horizontal, right? So our reference triangle has an opposite side equal to 0, doesn't it? Okay? Agree? as an opposite side equal to 0. So what's that cosine going to be? Cosine doesn't depend on the opposite, it depends on the adjacent, right? So it looks like this triangle, doesn't it? But is the x positive or negative in this case?
Negative.
Negative. So that should be equal to what? -1, because we went to the left. Good. All right. We'll do more of these next time. But I'm really trying to hammer home, if you haven't noticed, that you don't have to memorize all that much to figure these out. Okay? You only need to know a few of them, and you can figure out the rest. All right. Have a good one. We'll see you on Monday. Have a good weekend.